In this case study, you will open up an assembly and then create the appropriate joints between the components. Put a keyway into each of these two shafts so that it will be easy to see them turning. So one of these is an input shaft and the other one is an output shaft. Then in dynamic simulation, set the motion such that the blue carrier is grounded or zero velocity for 6 seconds, and they have a harmonic motion, then changing to 360 degrees per second over the next 5 seconds, and then have it hold steady. Then the purple sun gear, we want to set it at 360 degrees per second for the first 5 seconds, and then set it to the sun to dwell for the remaining 10 seconds. When we play the simulation, then we'll display the velocity of the green shaft, the purple shaft, and the blue shaft. You may need to change the colors of these revolution joints so that they match the gears. So in the grapher, change the properties of the graph colors, and then capture this in a screencast recording and submit the URL to Plato. So let's look at what the behavior should be. So that Word document, the lab report, is on your Plato Dropbox, and so I'll go ahead and play this. So first, this shaft is turning clockwise and this one is turning counterclockwise. This is held. So if you drove an automatic transmission car to school this morning, or the last time you drove an automatic transmission car, it would have at least two gearboxes like this, sun and planet gears, one feeding into the other to give you the forward and reverse gears.